The classical Newtonian physics talk about mechanical events such as forces acting on the matter. It mostly deals with the law of motions and gravity. The classical Newtonian law can be used in calculating motions of objects from solid, liquid, spacecraft, and so on. Basically, everything of the visible universe. However, classical Newtonian physics fails when we proceed to the quantum realms. Quantum mechanics talks about the theory of matter, or more specifically, theory of small components over a small scale. As we all know, everything in this world is made up of particles such as electrons, neutrons, and protons. In the classical Newtonian law, every object has a mass and has an energy. However, this only works on a larger scale.
In the beginning of the 20th century, scientists such as Broglie, Rydberg, Einstein began to question the nature of light as new evidence showed that light showed definite characteristic of a particle rather than just a wave.
In this video, we're going to prove the quantum theory of how objects can act as both a particle and a wave, specifically light particles through the double-slit experiment. Take this rice particle as an example. How can we truly understand its characteristics through this experiment? Say we pour these rice particles down a single slit, we will see a pattern on the back screen where the rice particles will simply pass through the slit. When an additional slit is added, obviously you would expect to see the same pattern created next to the previous slit. Now let's take a look at the characteristics shown by a wave. When a wave passes through a screen, it will travel at a radial motion all the way to the back screen. The highest intensity will be shown directly aligned to the slit. This intense and bright line is exactly a duplicate of the line pattern created using our previous rice experiment. But guess what? When we add a second slit to this experiment, the result is absolutely interesting. When the crest of one wave meets a throw of another wave, they simply cancel each other out, causing an interference pattern to be created on the back screen. At a position where two crests meet each other, the intensity it gives will be the highest and thus producing the brightest line. To sum up in an easier understanding, with matter such as rice, when you pour it through a double slit, the result that we will get is two bands next to each other aligned to the position of the slit. With waves, we'll simply get a pattern of interference caused by many bands.
So far so good, because that's not what we're doing here. We're diving deep into quantum world. Imagine a tiny particle of a marble, and imagine that as if it was an electron. Try shooting that into a single slit. You'll see that it behaves the same way as when we drop our bundle of rocks. You'll see every single electron all positioned in the same way as the slit. Let's try passing it through a double slit. Supposedly, it should show the exact pattern as the rice. You should be able to see two bands next to one another. But wait, look! It showed an interference pattern instead. How is it possible? We shot tiny matters of electrons, not a wave. Now how could a particle create the same pattern as if it was a wave?
Eventually, they concluded a hypothesis. A single electron supposedly leaves as a particle and become a wave of potential, passes through the slit, and eventually interferes with itself. There are endless possibilities. They could go through both slits, neither, or simply one slit of another. And they are all superpositioned with each other. Half a century later, even we're still amused by this. The big question is, which slit did the electron actually pass through? So they put a measuring device near the slit, all closed up and near, just to watch where it goes. But weirdly, so weirdly, the quantum behavior goes so far beyond our knowledge that its rules with the universe still remain a mystery. As we watch the electrons being shot through the slit, it comes back to behaving as a particle, not a wave. It produces two band patterns, not an interference pattern. What? So, does this mean that when an observer is present, then the electron will only pass through a single slit? Why, yes, it does. The electron decided it wants to behave differently. It wants to show that it's a particle, not a wave, as if it was aware that there are people watching its every movement. At this very moment, physicists asked again and again, what is quantum? Why does it behave as if it was both wave and a particle of matter? Which is correct. Why did the observer collapse its theory simply by looking and watching the electron go through the slit? And it all remains a mystery.